All right. Hello everyone. Thanks for joining. I hope you're having a wonderful Thursday so far. Very close to Friday. Almost weekend's almost here. And today I just wanted to talk very briefly about predictive maintenance for backup and recovery. I don't know if anybody out there is going to celebrate St. Patrick's Day today. So if you are, happy St. Patrick's Day. It's been quite the month actually. There's Pi Day, there's St. Patrick's Day, and of course International Women's Day. And this is probably the best part of it, that I get to speak at Voices again. So thanks, Diana. Without any more disturbance and talk about like anything else, let me get started. So today I'm going to talk a little bit about predictive maintenance for backup and recovery. I really don't want this to be a data science kind of a session. So those of you who have data science and backgrounds in data modeling and statistical analysis, I hope that when the takeaway that you take from this session is really how we could use it in the backup and recovery environment. I work for Veritas Technologies, and most of my experience really has been backup and recovery and storage management, though I'm also passionate about green technologies and Internet of Things now. So I hope that is like a takeaway for you, because I'm really going to do like a bird's eye view of what predictive maintenance is and predictive models are and how we could use it in backup and recovery. So this is what the agenda really looks like. I'm going to cover a little bit of, like I mentioned, predictive maintenance, talk about what predictive maintenance really entails. I mean, you need to have predictive analytics to even come up with a predictive maintenance strategy. And what is the need for predictive maintenance? I could not resist putting this in. I wanted to put a real life example of where you could use a predictive model. And well, mango pudding is something that I absolutely love, but so I could not, I had to include it in today's presentation. So that's an interesting real life example that I wanted to add and just explain predictive model in a regular use case where you can use it on a day-to-day basis. Wanted to touch upon the backup and recovery environment. What are the components in it? What is the workflow of a customer case resolution? Again, this is really close to my line of work. What I do is I work on customer escalations. So it is essentially how I resolve a customer escalation and what are the defect identification mechanisms that we use in our product and how do we better our product. So this is usually a standard workflow, more what everybody calls like a troubleshooting way of resolving a customer problem. And then I want to add intelligence to this troubleshooting mechanism, use the predictive modeling that I'm going to introduce, and introduce it and use it in a couple of use cases that we see, and see what the outcomes are at the end of it. So that's what I want to basically touch on. That's my agenda. So what exactly is predictive maintenance? It is an intelligent mechanism to predict anomalies and failure patterns in a specific environment. So it's very important here to collect data from multiple sources. You need to have a really good data set so that whatever maintenance, whatever model you derive, and whatever the predictors, I'm going to talk about it as we move on, but I just wanted to emphasize that it is important here that you have a valid data source, a valid data set. And as we move on, I'll try and explain how we collect data from the customers. And of course, it is driven by predictive analytics. So, what is predictive analytics? Predictive analytics uses a predictive model for prediction of future probabilities and trends. Predictive model comprises of multiple predictors. A predictor is a variable that can be measured for an individual or entity to predict future behavior. This model, when subjected to analysis, can be used to forecast future probabilities with an acceptance level of reality. So it is so crucial in today's environment that you reduce the downtime whenever you have a problem. In our backup and recovery environments, customers have some kind of a solution, like they have a disaster recovery site when one of the sites goes down, but even then it can cause a lot of problems in terms of unavailability of resources. You have to juggle around the policies, you're not able to run certain backups, so that causes a lot of problems and dissatisfaction from the customer end. And all of these, we really want to minimize it, especially in today's environment where we're absolutely imploded with the amount of growth in data. So predictive maintenance, really, I want to categorize it where the use of it is in 3 buckets as I see it. One use of it is in customer analytics. Second one is in operational analytics. And then there is threat and fraud analytics. So what do I mean by customer analytics? So I touched upon it a little bit. It's essentially to reduce the downtime and improve the customer satisfaction. So there's a number of ways in which customer satisfaction is monitored. So you want those scores to go up. And the only way to go up is, you want to minimize the downtime in the customer environment. When I talk about operational analytics, I really mean that what is it that you can do within your environment to protect or ensure that those assets are always functional. So it could be processes which are consuming a lot of memory, or it could be other in a software environment, it could be other problems that you should actually detect or foresee beforehand so that you do not run into downtime kind of situations. So now I come to my favorite example, that is the mango pudding example. That's what I call it. If, for example, you are deciding a menu for guests who are going to visit you, who you don't know much about, and you're trying to determine, should I add mango pudding? I mean, if you would ask me, I would say, who wouldn't like mango pudding? I mean, everybody likes mango pudding. But maybe I could be proven wrong, or there is a restaurant out there who wants to include it and see if anybody is going to order it in their menu. So I'm going to use this sort of an example with this background to understand what predictive modeling really is. In order to understand, or in order to devise this model, we need to come up with predictors at the end of this exercise, which are going to indicate whether I should include this or whether I should not include this in my menu, or whether anybody is going to like it or they're not going to like it. So if I can consider historical data, now I have considered only a few variables here. And traditionally, you collect this historical data either which way. These days, you have a lot of telemetry sites where people use this as a way to collect data. So if you install some products, at the end of it, even when you install like NetBackup, at the end of it, it will ask you a question: do you want to participate in improving this product? And if you click on it, it actually, what it does is, in the background, it starts collecting this information. So this is this is good. Like what I mentioned earlier was, you need a really large data set. You need varied data set to sort of make a good prediction. And telemetry could be one of the ways in which you collect data from various sites, from various different sites, not only on your own like historical data that you're collecting, but other larger or smaller environments, different configuration of environments. When you collect this data, another very important part when you do a predictive modeling is to ensure that it's not a dirty data. Sometimes there are corner cases, or there is just incorrect data that is gathered, which could like completely change your predictors, and you do not want that. You want like a consistent predictor. So traditionally, after we have all this data to develop this model, what I've done here is I've broken up this data set into two parts. So if you look at what I have mentioned just below historical data, the table, I'm monitoring age, I'm monitoring whether that person, eats mango, I'm monitoring whether this particular person likes dessert, and I'm gathering what eventually I want to come up with as a predictor, whether they will like the mango pudding or not. So these factors are actually making me kind of, driving me towards whether they're going to like a mango pudding or not. So when I collect this historical data, I break it up into two sets. Like I've broken up these rows into the training set and the testing set. What I want to do at the end of this modeling exercise is really to run it through the testing set and see whether my predictions are matching to what my data really was. Once I have this training set, I kind of come up with algorithms. Now, there are various ways to come up with algorithms, and these are like really machine learning kind of exercises. You have it's very complex data science mechanisms in order to sort of come up with an algorithm, and that's why it's called a science really, to come up with like an algorithm as to, to reach a conclusion and have a predictor at the end of it all. So in this particular exercise, what I've done is I've just used a decision graph. So it's a really simple way of coming with a predictor. So here what I've done is I've started with the mango node. I'm checking whether, if it's dessert and mango, then what is the probability of that person liking a mango pudding? Or if that person doesn't like mangoes at all, what is the probability? So I've come up with a ratio here, and using this as a predictor, what I'm going to do is, this is my model now. I have like sort of an algorithm, a tree here, a decision graph, if you were to say that, and use this model to actually come up with a test to verify whether whatever I have generated is worth even like, using, or do I have to go back? And it's an iterative process. So do I have to go back and redesign my algorithm, relearn from whatever conclusions I've drawn. So once I have this algorithm, what I'm doing is I have a model ready now, and I'm going to run it on the testing data. So from the testing data, I had one column which I had one row which I had separated out, which said that, for this person I'm calling B from the list, likes mango, likes dessert, and I'm going to run it through my predictive model and see if whatever I had received in my historical data matches really with what I'm predicting, and it does. So this is a good model now to run on new data. So now I've validated. It's a validation process that I've completed here, that yes, whatever the predictor I had, my predictor here was like, and my value which I've derived for the predictor is working as expected. So really, what I'm going to do henceforth is do some kind of predictive scoring. I use my algorithm, I use my model on the new data, and then it gives me it's kind of a forecasting as to whether that person will like mango pudding or not. And it helps me make better decisions as to should I have this on the menu or not. This is what I would call like a gut feeling, really, but it's putting it on paper and deriving using whatever data that we've collected to make intelligent decisions. Moving on from the mango pudding, what are the components? And now looking at serious stuff here, what are the components in a backup and recovery environment? What I do is I work for NetBackup, just to give you a little bit of insight as to why I've included this in my presentation. So we deal with backup and recovery. So NetBackup is nothing but a product for backup and recovery. And what are the components it includes? Essentially, this is a very bare bone model. It's going to back up clients. Now, clients can be various workloads. I've just included some workloads here, like SAP, SharePoint, Exchange. It has a master server, which is more like a driver. It will run these policies on a particular schedule to back up data from various clients. Media servers actually they manage where this data goes, so they kind of manage all the media, and it's kind of an interface between the master and the clients. I just wanted to give like an overview of what this environment looks like so that the later examples and the use cases that I'm going to talk about would make a little bit more sense. So when you have problems in these environments, then it comes to how you resolve these problems. It could be various problems ranging from, this environment being down, not accessible, network issues, performance issues. There are like tons and tons of problems. You see error codes and you try to understand what exactly this error code does. So a typical workflow of a customer case, and what you call really is a descriptive way of resolving a problem, is to identify the problem. You look at the problem, use your knowledge, look at tech notes out there, look at error codes, look at code, try and figure out what the problem is. Once you do the RCA, then you correct this problem, you verify the solution by running it in your test environment, and then you avoid the reoccurrence of this problem by fixing it in your product release. So it's a very descriptive, what they say, a descriptive way of solving a problem. You know what the problem is, but there is no predictive. What if I apply like whatever I learned with the predictive model example, the mango pudding that I just was talking about a few minutes back, to this particular situation? Can I do anything? So let's look at a couple of use cases. So as I talked about, green technologies, it is something that it's one of my favorite areas, and I wanted to touch upon the power consumption problem because we really don't have any way right now to measure the power consumption in a backup and recovery environment, but it's in a POC that I worked on, and I find it very interesting. So if you look at a power consumption problem, what I think is you want to look at, if there is any erratic power consumption, or there's increased power consumption, or there's some kind of problems with the CO2 footprint. So we have an analytics and troubleshooting, analytics dashboard, which gives you just a quick overview of what your environment looks like. This is the Op Center analytics that we use. So there's like master servers, gives you insight into what are the jobs that are being run. And if you look at the on the right hand side, I would embed something called as a green meter. That's what I call it. Where looking at a green meter, it would give you an idea whether there is something wrong. So you have various zones here. You have the green zone and the red zone. And if the arrow actually points to the red zone, it kind of gives you insight, a quick glance, and you know that there is some kind of erratic behavior in terms of power consumption within your environment. There are various ways in order to capture this information in terms of what are the variables that could essentially be monitored and used to come up with a predictor value at the end of it. So some of the tools that I used were very rudimentary, regular available tools, not very specific to this backup and recovery environment, but you can download Joule Meter, there's IPMI tools, and all these other various bindings out there like JoleX, which you can incorporate and use it within your product to sort of give you an insight into the power usage. So here is some data that I collected. MSDP is nothing but a deduplicated disk, deduplicated storage unit that we use. And I thought that these parameters would be interesting to capture and see the relation between them and the predictive analytics and the predictive model. So a couple of things that I collected here was the power usage of CPU, power usage in terms of different variant storage units that I used, and I ran, and the volume of data. So how much of data is being backed up. So this is all the information that I collected. Now, using the predictive model that we used in the previous example, if I am the variables that I have used in this particular example and use case is, say, for example, amount of data, number of backups, whether that disk or the storage unit that was used, did it have deduplication? So these are the variables that I've used, and I'm hoping to come up with a predictor in this particular situation. So I run it through our model and try and come up with a predictive scoring model in which, I have some relation which I've established between all these variables. So the data and the backup, disk, all these variables, somehow if they're correlated, and I've sort of made sure that my predictive model is working in that environment, in future, I can use this scoring mechanism, and if I use it in a customer's environment, I would sort of be able to predict that whether they are going to have erratic power consumption problems in their environment, what is the amount of data that is getting backed up, how many backups. So if I collect this kind of information on from a real-time customer environment, I should be able to make this predictive scoring. And essentially, I want to use this model to what they call prescriptive modeling, which is essentially trying to find, when I see this problem, now I've forecasted this problem, how can I use this knowledge to counter this problem? So this can lead to some kind of process improvements. So essentially what I can do is, once I kind of predict that this is the environment that could have these kind of problems, I will proactively use power efficient automated policies. I can design power efficient policies and automatically, when I kind of get to a certain ratio of what I think that it's going to cause a problem, I can switch these on automatically or use power efficient components. So there's multiple ways to tackle it, and all this knowledge that we've gathered not only leads to better understanding and better forecasting of the environment, it can also lead to a lot of interesting process improvements. The second use case that I really wanted to talk about was performance problems. And these are like the most hardest really problems to sort of resolve. I'm sure a lot of you out there have seen this. And in order to even tackle these problems, it is important to establish some kind of a baseline of performance that you see at the customer's end. And all the historical data and the telemetry data that you collect and analyze can help you establish these baselines. So common problems that we see, and I've just listed them here, are degradation during backups and restores. So I've not added very specific cases, but these are the basically what the problems are around. So in such situations, what you have to, in order to prevent such situations from happening, the data sets or the information that you would collect in order to run it through our predictive model would include data such as system information, file information, network information, process monitoring. There are a number of tools again out there. You can use any of your own tools. Like I'm going to mention one of the tools that it's like a homegrown tool that we use when we kind of identify that it is a file system problem. So you can use STOP, you can use to get process information, lots of performance monitoring tools out there that you can use to generate these data sets. So for example, if I were to use NB Perf Check, this is our homegrown tool, it would indicate over a period of time whether I'm going to see a disk performance related issue. And to tackle these, in Net Backup, we have some configuration and profiling parameters that you could use to sort of tackle this problem. So as a auto-tuning way of resolving this problem, not only when I get this and understand that there's a problem, I can improve this process to turn on these auto-tuning capabilities, automatically start using these newer configuration parameters in your environment, or learn about scheduling these activities at a given point of time. So that pretty much covers what I really wanted to talk about today. It was just an overview of using predictive maintenance in a backup and recovery specific environment. And I thank you all for listening.
Great presentation. Thank you so much.
Thanks, Diana.
So we have a chat window that's down at the bottom of the screen if you want to ask a question via chat. And also what I will do is I will unmute everyone so you can go ahead and ask your question via audio. So if anyone has any questions, feel free to ask at this point.
Great presentation. Thank you.
Thanks. Thank you, everyone. Thanks for listening.
All right, so I'll go ahead and wrap up this session, and I'll put the recording online, and it should be available in less than an hour, or it's $3 off.
Sounds good.
All right.
Thanks, Jenna. Thanks for this opportunity.
Thanks,
So fun to
everybody.
watch your voices. Yeah,
All right.
bye.
Thanks, Dhanashri.